So this video going to cover CFA first order model. We have seen the fundamental of CFA SIM and what is theoretical understanding behind and when to use SIM and how to use SIM with the help of software called AMOS. Now since open source is catching up and lot of things we can do it in open source, then it is good suggestion to start through the R also. So this session we are going to cover fundamental of how to use CFA using R with the help of Lavon packages. So first of all, we have to install the packages and we already installed. Only we have to invoke the library called Lavon. Lavon is the packages meant for a fundamental of CFA first order, second order and SIM and also mediator moderator using a SIM framework. So we are taking the same old data called HR benefits data, what we used for EFA model. We just seeing what all the variables are available, and there are totally 13 items are there, and we know that a lot of missing cases, so we remove the missing cases also. Now here in CFA using R, there are a few steps you have to follow. One thing what we called as a model step. Okay, this model step is almost what we can call as a model specification in AMOS. So in model specification here, this is our latent. There are two latent we declared here, and these are the items. You can see the items what you have taken from here: basic, perks, and incremental. Since it's a demo, I'm just taking only 3 items to measure a latent called monetary. And same thing we are repeating for recognition, fairness, interaction as a career orientation or career opportunity. So this is what we call as a model now. The model specification contain 2 latent, and each latent contain 3 items. Normally in while making a diagram in a AMOS, we'll make a kind of a marker variable or var regression weight. So by default it will take the first variable, we no need to mention at all. And establishment of a latent and items, the relationship is indicated by this sign. You can say equal to tilt symbol, which includes or which speaks about reflective indicator. Now somebody want to do a formative indicators, then the same way we have to use a symbol called less than and tilt. So it is meant for formative indicators, and reflective indicators is equal to tilt. So that's it. And you can see this is a very important. It is not something we just made without our knowledge. This is an important kind of block command. So this whole model is working inside this command. And whatever you want to give as a model, whether you want to make a regression or a correlation, covariance, or co-varying the errors, this all the things should come only in this inside this model only. So just for a namesake, we can say it is a co-varying errors. So here I can just make a co-varying errors. The next step, what we can call as regression equation. So all the things has to come inside this block. So this block is more important. While running also, we have to select this whole block together. Otherwise, it will throw error. If you just selected only these things, and it can't understand because the block is incomplete and it won't execute our things. So it is advised always to just when you're running, select everything together and run it. So we just run this, then it accepted. Now the next thing is, you can see there is a data come from what we can call as a HRB. Later on we removed a missing case, then it became a CFA HRB. So now we have to connect all the things in a single function. That function what we can call as CFA. There is no big difference between CFA function and a SIM function. If I'm going to use a SIM function, you have to type SEM SIM. CFA, just put CFA, that is more sufficient. Now the two arguments we have to pass here. One is what we call as a model, other one what we call as a data. So model, what we just given inside this block commands, that is what we can call as a model. So you have to pass HRB model here. And when you say data, the data come from CFA HRB. So these two things has to be connected. And this connection has to be made in the object name called model fit. So let us run this also. So it accepted. Now we have to see the output, how it look like. Even if you just type summary model fit, you will get the output. But to make output more sophisticated, more informative, we are adding one more thing called standardized true. This standardized true will fetch a not only covariance based score, it will fetch a what we can call as correlation based score also. Normally in Amos will go and will click on something called what we can call as a squared correlation and standardized score. We just keep on enable. It is almost like a same concept here, standardized true, and R square meant to just fetch R square, and fit measures all kind of fit indexes, which includes good indexes, bad indexes, which we have seen in our presentation. So now just to run this, select all together and run this command. So let us see how the output look like now. So the output starts from here. It shows it has taken 37 iteration in things. Number of observation is 77565, and estimator is we are using ML method. I hope you people may remember now why we used the EFA ML method, because by default software like SPSS or any proprietary product will keep a PCA method, which is not at all factor analysis. So when we do in R, we'll use a FA method, and we just done a ML as a estimation method. And here we are extending the same EFA with a CFA. So, and here by default method is ML method. So estimator is ML method. Model fit statistic shows 341, and degrees of freedom is 8, and p value is 0.000. So in this place, ideally the p value should be more than 0.05, but most of the times you won't get, because sample sensitive of chi-square has got problem of sample sensitive, and there is other concern also. So we never bother about this p value as a fit of indexes, but we have other fit indexes like TLI, CFI, GFI, NNFI, and bad indexes like SRMR, RMR, RMCA. Anyway, we'll see one by one in the upcoming session. Now this model statistics model test baseline model. So it is look like the figure of is very high figure. So now the figure is 51,268. It's a big figure. Now here 341. So when you say this model, what we can call in Amos language called as a independency model, and this is what we call as default model or the proposed model, what the output we got it. So the any iteration further, the figure should go below this, then we are saying that we are traveling towards a saturated model. Okay. Now let us see the further information about CFI TLA. CFI is 0.993 and TLA is 0.988. That looks good. Then we have a archaic information criteria. Then we have something called RMCA. RMCA is also almost close to less than 0.05. That also seems to be good. Then if you are SRMR, SRMR is a 0.02. That is also seems to be good. Now this all shows like a fit indexes very first. In almost first it will show the estimation and followed by fit indexes. Here it's a reverse case. First it will show the fit indexes, then it will show the estimation. So in terms of estimation, you can see this is the latent variable, and this three items what we can call as a manifested variables, or we can call as a item. So this estimation is what we can call as unstandardized estimation based on covariance. It can go more than one also. And this estimation what we can call as a standardized score is based on a correlation. This cannot go more than one. That is more important. If it is going to get more than one, this information, the standardized dot all, then there is some concern about A wood cases and some extreme data. Then we should have some kind of treatment for that. Now the same if you take carrier, the second latent, all the variables seems to be good, and p value here we won't call as a CR like what we call critical ratio in Amos. Here we will call as a Z score, okay, or you can say you will call as a Z value. There is nothing but your CR value. So all the values are more than 1 point plus or minus 1.96, and p value is almost like 0.00. And the covariance speaks about, okay, when you see this the model, one interesting part is while running the analysis we never correlate two latent variable. Automatically R will do that. So with help of 11 package R is doing that. We no need to correlate anything. If there is a latent is declared, it is automatically correlate. Even if you have 7 latent variable, we no need to keep on relating with the one with the other, then it will become too much of cumbersome. So R has got a big intelligent system here. It will automatically correlate whenever we are declaring a particular variable as a latent. So it shows correlation is 0.691. It's a pretty good, and covariance is 0.113. And the variance is quite important for us because variance, we have to see any variance are big figure. So if a variance are too big figure, that is a concern for us, and variance cannot be negative at all. So as of now, there is no negative variance here. So this indicating that the model is perfectly fit for a statistical purpose. Then there is a R square. So each one indicating like almost everything more than 0.5. This all indicating results looks really good for us. Now, whether we want to improve the model or not, we will see further. Then how to put this model in the form of a graphical or a diagrammatic representation. So here you can see very simple here, we are using a package called a semplot. In that we have a sem path as a function. So whatever we just got here model fit, we are passing here again. And fit layout, there are various layout, is there like a circle, tree and other layout is there. Most of the times we will use a tree layout. And rotation, whether you want a left hand side or right hand side or top to bottom, bottom to top. So we can use a rotation 1, 2, 3, 4 you can use. Then style is a literal style. So the literal is one of the original software for SIM. And if you just want to look like the output should look like a literal, then we can use this logic. So select this. So this is what is a model specification what we got. And one thing we should understand here, in almost first we'll make the diagram, then we'll proceed further. But here the things are reverse. So first we have to make this block comments. This block what we call as a model specification. Now we already done all the analysis. Only thing is we have to get the output in the form of diagrammatic representation. Just select everything together, control enter. Now you can see this is the output what we got, and some lines are so thick, by default you can see dotted line. Dotted line is nothing but it's a marker variable. It's applying a first variable as a default as a regression weight. Then we can see when the lines are too dark, it means the relationship is too high. When lines are too thin, but in this case everything is more than 0.7. In some cases you will get a very thin line and very thick line also. Thin line indicating relationship is a moderate or low, and thick line indicating relationship is a high. So here everything 0.7, 0.85, whatever we have seen here, if you just see these things, okay, whatever the figures are seen here, in case of a standardized regression, you can see the figure here 0.76 is basic salary. So you are getting points, a rounded figure 0.77. Here 0.8, 0.846, here 0.8. It's a rounded figure of 2 decimal. So this is how the output look like. So once we get the output, then we can start collating all the output and we can show it in a much neat way. Now let us go back and see is any chance for us to improve the model in the model modification with help of modification indices. So let us, this is a command, modi indexes, model fit and sort true, and minimum value is 4. Sort true, so it will show that the changes required for the topmost one by sorting here. So control enter. So once you control enter, it will show the figures are there. So recognition and fairness, yes, it is look like a 247. The two things come from the same constructs. You can see recognition and fairness. So it is come here. So we can able to correlate this. If we able to correlate this, the figures are 247. So we can say drastically it will improve the model. So simple way in R is just copy this. That's a one great advantage here. Copy this and just go to your code, and inside this block we have to paste it. Okay. So what's the next job is run once again. We can select all together and we can run together. Control enter. So you can see now it's a newly added one. It is just added. Now one thing interesting point is by adding the error, by correlating the error, none of the figures or estimation going to change. So it is more about just getting the statistical rigor for the model. Theoretically it is not going to make a big changes at all. So anyway, we'll just examine the outcome, the revised outcome once again in terms of fit indexes, because it will reflect only on the fit indexes. So fit indexes, if you're going to see here, it was a big figure earlier, now it become below 100. So that is fantastic. So it shows that our model is traveling towards almost like a zero of, means towards a zero. It is not actually exactly zero, it is a towards a zero. So mean to say our model is traveling towards a more saturated way than an independent way, because independent model is a big figure. It is, the figure was earlier more than 300, now it has come close to 99. So then if you see all these figures jump like anything, 0.99, 0.996, and SRMR, RMC, it's almost 0.207. Then SRMR, if you just see, yeah, it is 0.008. So one thing is, we have, this is not a exact, it's a hypothetical data. Just to make a demonstration, we are showing this kind of data. In ideal situation, we may not get this kind of good figure also most of the times. So we have to see, unless we have a good theory, good data and good model, then SEM is really a wonderful job. Otherwise, we don't have a strong theory and your model is not rooted through theory, or we don't have good quality of data, too much of extreme cases are there, then we have to struggle a lot to get a good output from the same. So all the things are there. Whatever you have seen is as other figures are same. So beyond, it doesn't require more improvement. So the next job is we have to just report this output in a very structured way.